Okay, till where we have actually written? I think we have written till the kinetic energy and the light frequency, and also electric current versus the light frequency. What was the last thing we have written? Can anybody please tell me? Yes, hello.
It was the result that we found from the photoelectric effect.
No, no, which results? I mean, yeah, I mean, this one have we written? This the thing which is right in front of you.
Yes, I think we have.
We have written that. What left behind? Okay, now let's start with the formula, right? Now, there are different ways to write the formula. First thing is called E photons is equal to KE electrons plus the work function. It means that whatever energy which are coming out from the metal, first of all, you required a minimum energy, or you can say threshold energy, so that electron will actually ejected or knocked out from the metal. Then definitely whatever energy you will have it for the electrons, electrons will have that energy, right? So it means that E photons, you can have E photon. If I ask you what is E photon value, then it must be H frequency. How can we give this energy? We know that there is a scientist named Planck's constant. By using Planck's, we can give the energy as E is equal to H frequency, or you can give H mu, right? So now the formula become H frequency or H mu is equal to KE electrons plus the work function, right? It means if we want to find out the energy of electrons, then it will be K electron energy is equal to H frequency minus the work function. So I want you to write from here to here and see if there is any problem. Phi got the unit joules. Remember that. The equation that is Ke electron is equal to H mu minus phi is the equation of photoelectric effect. Once you write it, let me know.
Um, what is the in HV? What does the V stand for?
V, what is V? Which V? This one? This
What
one?
is it? It says E photon. Yeah, E photon
E.
equals HV.
No, no, it's HF, not E. F.
No, no, like in what you like put in brackets, there's like E photon equals HV.
No, no,
Is that
it's
supposed to
not.
be an F?
No, 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 it's F. HF.
Hello.
As per the Planck's constant. You know that Max Planck. How are you, Zoha? Where were you?
Sorry, I was having internet difficulties in
No
my
problem.
home.
No problem. It was initially when we started that writing, we have seen that there was a scientist named Max Planck, and he have given an equation that is called E is equal to H frequency. So this E photon is equal to H frequency. That it's not E, it's F. Or in other words, sometime instead of frequency, we use this symbol as well. This symbol is known as mu. This is
Yeah,
also
that confused me.
that is also F technically speaking. So don't be confused with this symbol or F. You can use F instead of that as well. Wherever you find mu naught, it is actually F naught. So don't be confused. It's just a symbol they use it. You can use that symbol as well. So
For
the
the symbol for work function, our teacher said that it can be confused with other symbols, so she told us not to write it.
it's up to you. But if you want to use it, see, when especially a question for the, photoelectric effect comes, then I don't think so. It will be confusing because definitely in the photoelectric effect, you will not be using that symbol related to heat or something. If you're still confused or you think that it will be confusing, write the name of the symbol as well with that. Like for example, if you write this function, this symbol, use work function right in front of it, like that. So it will not be any more confusing. But why we are writing
Okay.
in a symbolic way so that our work will be quite shortened in that way. Otherwise, if you write full complete equations all the time, it will be longer and longer and longer. You understand me what I'm saying? Once you write till there, just let me know. Now, once you understand with this, now I think we better try to use these formula into our question and see how actually we can use these formulas. So let's start the questions here. Okay, one more thing. Kinetic theory formula, we can use it as well. Now, this formula is very interesting if we want to use it. What is it? Check it out. This kinetic energy of electron can be given as 1 by 2 mv square. Now, here, because we are talking about mass, so we can use me. So, this formula will take another form, which is 1 by 2 mev square is equal to h frequency minus work function. Now remember that the mass of electron will be 9.1094 into 10 is to the power minus 31 kg. Now they wrote it as a rest mass. What do you mean by rest mass?
Mm,
When the word rest mass,
and
it's, I tell you one thing. Now, very important thing. When electrons start moving, we normally believe it moves with the speed of light, actually. And when it moves with the speed of light, it means it will become a massless entity. If as we move further, you will find out that all the, you can say, things which are inside the nucleus, they are moving very fast. So this mass shows you that there is a mass. It means we are believing that the object is in the state of rest when this mass is calculated. By the way, it's not calculated, it's just by calculation we found out. Okay? So this is the rest mass means object in rest. So this is the other formula which can be used. You can find out the velocity of the electrons as well if rest of the data is provided to you. So the same photoelectric equation comes in another form.
hello.
Yes, you finished?
Yes.
Okay. Now, once you finish with that, let's move forward further. The questions are here already. This is for the light, excluding the wavelength trend and everything. Now, I want you to try this. They say work function of a copper metal is this. They have given it. And if we shine light with a frequency of that hertz on a copper metal, will the photoelectric effect be observed or not? Can you check it out? Which formula will you use in this? Work function is given and frequency is also given.
HF minus phi.
By the way, H value is also, I think I have provided you the H value. If you didn't, then
Yeah.
take,
6.63 times 10 to the power negative 34.
yeah.
I have found 1.9 times 10 to the power negative 17, which is
I
approximate
got
to
the
2
same.
times.
So what do you
But
think?
how? But I don't understand, what do they mean by will photoelectric effect be observed? How do I use this information?
Now you tell me one thing. The frequency is given to you, right? And you have given E photon value, which is 2.0 into 10 to the power minus 17 joules. Now you tell me, is this energy is more than the work function, or is that energy is less than the work function?
It's more.
It's more. If E photon energy is more than the work function, it means that photoelectric effect will be observed. Very simple case. Because minimum requirement of the energy is phi, that is work function. So you actually provide the photon which actually performs or which actually provide 2 into 10 to the power minus 17 joules of the energy. So this energy is more than the energy of that is required, minimum energy required to a metal. So actually, when you subtract 7.53 into 10 is to the power minus 19 joules out of photon energy, you will find out the energy of the electrons, technically speaking. So in case of if energy of electrons you will actually found out, then it means that you are providing more energy than the energy which is required. Because this is our calculation again, that let's suppose if this is your metal or something, it must have a phi value. Your energy must be more than this work function. And the value is 2 into 10 to the power minus 17. That is the energy which you are providing. And the energy which is required is 7.53 into 10 to the power minus 19. Which one is greater? 2 into 10 is to the power 17 minus 17 or 7.53 into 10 is to the power minus 19? Yes. Which one is greater?
Of course, 2 times 10 to the power negative 17.
So it means that the energy provided is more than the phi or work function. Now you tell me, will the photoelectric effect will happen or not? You provide more energy. So definitely you can see the photoelectric effect. That's it. So the condition will be E photon must be greater than the work function. Check it out. E photon is greater than the work function. If this will be the case, there will be a photoelectric effect. If that will be smaller than that, then there will be no photoelectric effect. Understood?
No.
Problem?
No.
But no. You don't understand?
I didn't say no, I said yes.
Who said no? No. I could hear no. Okay, anyway, no issues. Okay, can you find me the energy of the electrons by using the same formula? I will tell you here another point. That will be actually E photons minus work function. So it means 2 into 10 raised to the power minus 17 minus 7.53 into 10 raised to the power minus 19. What is the value coming up?
Uh, 1.99247 times 10 to the power negative 17.
Negative 17. And what is the unit for that? Joules, right? That is the energy
Yes.
or kinetic energy of the electrons. Okay, now at this point, if you check it out, it's a very, very small unit, right? 10 raised to the power minus 17 is a very small value. So remember that in photoelectric effect, rather than providing the energy in joules, we found out another unit. We give it a name called electron volt. That is a very small unit. So how to convert joules into 1 joules will be equal to 1.6 into 10 raised to power minus 19 electron volt, technically speaking. Or you can say, wait, don't write this. It will be 1 electron volt equal to 1.602 into 10 raised to power minus 19 joules. This is the relationship. So if I ask you to convert this into electron volt, what you will do? You multiply it or you divide it by 1.602 into 10 raised to the power minus 19. Yes, students. If you have electron volt and you have to convert it into joules, you have to multiply. But if there is a joules, you have to divide it. So divide it, please. It will be, where is it?
Which one are we dividing?
1.924 into 10 raised to the power minus 17 divided by 1.602 into 10 raised to power minus 19. If you check this out, this is the charge of an electron, technically speaking. So what is the value coming up?
An even smaller value, 1.188 times 10 to the power negative 36.
No, check it out. How can it be negative 36? If this negative 19
Okay, I'll
will,
try.
because negative 19 when go in the numerator, it will become positive.
I'm getting 120.
Yeah, that's what I'm saying. You're getting 120 electron volt. Now this
Okay,
looks
yeah.
bit sensible. because 10 raised to power minus 17 looks very, very small. So remember that in case of photoelectric effect, you always provide your energy in electron volts because we are talking about electrons. So you have to convert your energy into electron volts. So one new unit come into your dictionary, or you can say that electron volt. So one electron volt is equal to 1.602 into 10 raised to power minus 19 joules. If you have to convert your electron volt into joules, you have to multiply. If you have to convert joules into electron volt, you have to divide. And did you notice that when you convert a very small value into electron volt, the value becomes a bit sensible, 120 electron volt or 2.5 electron volt. It makes more sense and the value can be easily actually written. Otherwise, 10 raised to power minus 17, minus 20, minus 17, very, very small values. So even this value is difficult to remember. Electron volt will be easy to memorize as well. So girls, understood?
Yeah. Yes,
Any
sir.
any questions? Alicia, Zoha, Manur?
No question.
No.
So this one question gives you so much idea about how to find out the calculation works. Let me just come to the if we have another form, I mean numerical for that. Can you try this? What is the kinetic energy of photoelectron ejected from the copper by the light with a frequency of 3.0 into 10 raised to power 16 hertz? So kinetic energy of that. I think copper work function is already provided at the top, so you have to use the same one because for copper it will be the same. Phi value is 7.53 into 10 raised to power minus 19 joules. For every single, I mean, metal or whatever, the work function value will always be the constant value. And
Okay.
I need I mean, joules value, I mean, not joules value, energy value in electron volts. All right. Write this constant value first. So I will move down. And your H value is Planck's constant is 6.626 into 10 raised to power minus 34. Manur, when is the examination for the unit one or and then unit two? Exactly. Dates?
The first one on May 7th.
May
May
7th.
7th, yeah.
And when is the second one?
Not sure about that.
And May 7th one is which one? Mechanics one or the waves one?
Okay, May
Mechanics.
7 is mechanics, and May
Yeah.
21 is paper 2, which is waves and electricity.
Okay. Now, after finishing this, right? Because May 7th is much more near and we didn't start even mechanics. So, what I will do after finishing this one, instead of moving forward in this, unit, I will leave it here. What left behind is energy levels, that different materials and everything in that. I will jump on mechanics. What do you say?
Sir,
Yeah.
Yes, I will be finishing
sir,
that.
what?
But my point is at this point of time, because your first paper is mechanics, so that's the reason I'm saying that. Let's jump it on that. And once we finish with that, I will come back to that. Very small topic left behind now. That quantum phenomena related to, hard-ons and, a different type of radioactive materials and all this. What's your opinion about that?
Sir, I
Yeah.
need to ask you something.
Please.
After this lesson ends, at the end, can I talk to you?
Okay, that's fine. Related to, okay, no problem. Please.
Okay.
Okay, so students, my belief is as soon as we finish with photoelectric effect, we will start working with mechanics. What do you say about that?
Yeah, I think it's a good idea.
Because the reason is the one which left behind is quite easy. We will do that as well. But because your paper is on 5th of May, so I better want you to start with the mechanics and each and everything. And then once it finished, then we will come back to the small topic left behind. All right?
Okay. Oh, wait, so we're starting mechanics next lesson, like on Tuesday?
Yeah, let's see if I can start it in the same class. If that can finish, then why don't we start with mechanics right now? Will that
Okay.
be fine? And what I
Yeah.
what I've seen Alicia has much more interest in mechanics than in waves. Am I right
Oh
or
no,
not?
because in school we're doing it right now. So
Okay, okay. I thought you liked mechanics more than waves,
no.
but you're good in it. You're practicing in each and everything, and if you're practicing, that's great.
Yeah, I'm fine.
You don't need to worry. But I will provide you so many questions that you will keep practicing. I tell you, I got how minimum in this topic. I have hundred of questions with me.
Yeah, because it's confusing for me.
Don't worry. Inshallah, once we start, you will see yourself that each and every confusion will be sorted because the way the question is being done in your book, which you just showed it to me in the that screenshot, that was difficult. That was confusing also. I will tell you a longer way, but that will be an easier way.
Okay.
Okay, what is the answer for this?
I got 4.65 electron volts.
4.65 electron volts. And what about you, Alicia?
Yeah.
Let's check it out. Manur, what about you?
Same, sir.
It's 1.9 into 10 raised to power minus 17 joules. Was it your answer?
No.
But they got this?
Wait, this is different. This is for the previous question, example 1.
No, this is example 2.
It says, wait, why are they using, don't understand.
I think so. Let me just check it out if they have anything. No, this is the. Did you use the Planck's constant thing in frequency and multiplication to find HF? What is HF value? You got it.
We got the same one 2 times 10 to the power of 17.
And when you subtracted, didn't you get this?
I got 1.8.
This is in joules, right? Now divided by 1.602 into 10 to the power 19. What is the electron volt thing?
Confused.
But why you're confused? You didn't get the answer?
Wait, let me explain. I thought we're not supposed to use everything that we've done in example 1, just that the work function is
Yep.
7.5 times
Okay.
10 to the power negative 19.
Okay.
So I just use E equal HF.
Okay.
I got 1.989 times 10 to the power negative 49.
Negative 49.
Yes.
So they use the expression from the previous one. Let me just check, please. If it is a case, then okay, they use this one. Okay. So why they okay? It's the same thing. 3 into 10 is to the power 16 hertz. Maybe you will have a calculation error. Check.
Yes.
Because let me check in my calculator. I got the scientific calculator as well. Let me just check. How come your value give you a wrong answer? 2 into 10 raised to the power minus 17.
Oh wait, I think I found the error. I put 3 times 10 to the power negative 16.
Yeah, that's what it is. Because it's the previous question.
So now I got 1.989 times 10 to the power negative 17.
And now divided by 1.602 into 10 raised to the power uh, minus 19. And it gives you 120 electron volts. So this is 120 electron volts of the energy an electron have it. Now remember that in general cases, when photoelectric effect happens, you will have this much amount of energy. You cannot have more energy than that. Don't think of it that you produce lots of energy by photoelectric effect. It's not possible. Or what you think that in some countries start generating electricity by using photoelectric effect, then this will not be the case. It cannot be possible. Remember that, please. So this is not the process of generating electricity. All right. So understood photoelectric effect?
Yes.
Good.
Yeah.
All right. Now, At this point, I'm leaving this, what do you call this? Uh, what is this thing called? This waves and quantum physics for some time, and rather I am jumping on mechanics first quickly. And let's see how good concepts you have it. So let's start with the mechanics now. Now, quickly, let's quickly have some review related to the mechanics thing. Whenever you talk about mechanics, what actually you study in mechanics? What is mechanics? Quickly.
Movement.
See, whenever you talk about mechanics, it means something related to motion. Remember that. So it means you are studying the motion. So mechanics, if I ask you, mechanics is a study of objects in motion. Mechanics is a study of objects in motion. There is another name of that. We called it kinematics as well. So kinematics, mechanics means the same. No difference at all. There is another name you may heard of it, dynamics. So all are interrelated. Now, when you're talking about kinematics, we already have a IGCSE knowledge that we should know what velocity is, what speed is, what acceleration is. Quickly, I will ask you one by one and then we will move forward because this is not my topic actually. What is speed and what is velocity? Yes.
Speed is
physical
distance
quantity
traveled
So basically distance traveled
per unit time.
per unit time. And velocity is displacement
displacement.
divided by time, or you can say distance in a particular direction. Speed is not in a particular direction while velocity is in a particular direction. So basically, speed is a scalar quantity while velocity is a vector quantity because it has a direction. And what is the unit for that? Speed?
Meters per second.
Meters per second. This is SI unit, remember that. But other than that, there are commercial units as well, like kilometer per hour, miles per hour. These are the commercial unit used for that. After that, we will have another quantity called acceleration. Now, what is it?
Change in velocity per unit time.
The easiest way to explain that is the rate of change of velocity. Whenever you use the word rate, it means divided by time. So basically, A is equal to change in velocity divided by time. Right? Change in velocity divided by time. What will be the unit? Change in velocity means velocity. So velocity is in meter per second and time is second. So acceleration SI unit will be meter per second square. Other commercial units are kilometer per hour square, miles per hour square. Right? This is for our previous knowledge, whatever we have it. Now, at this point, once you understand all this and everything is, if you write everything, then let's start something. Did you write everything?
Yeah.
Okay. Now
Yeah.
write few lines here. Let an object is moving with the initial velocity u. Let an object will be moving with the initial velocity u, capital U. After time small t, after time small t, the velocity changes to capital V. Velocity changes to capital V. So the acceleration A, so the acceleration A of a body can be given by A is equal to final velocity minus the initial velocity divided by time. Alicia, what shall I put here instead of final velocity as far as symbols are concerned?
Final velocity is v minus u over
Upon
t.
t. Right. Now you can manipulate the formula, cross multiply this t with a, so you will have at is equal to v minus u. So v will be equal to u plus at. This is one of the equation of motion. We called it equation of motion. There are two further derivations we have it, so we will do that. Okay, at this point, I'll ask you a further question. What if your V is greater than U? What is the value of A? Will that be positive or negative?
Positive.
Positive.
Positive. So it means that if V is greater than U, it means that velocity is increasing. And if velocity is increasing, A is positive. In the second case, if V is smaller than U, so if V is smaller than U, velocity is reducing. And if velocity is reducing, what is the A value?
Negative.
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 Is there any special name for a negative acceleration?
Deceleration.
Deceleration. So there are two, three names of it. One is called a negative acceleration. One is called as deceleration. And another name is called as a retardation. When acceleration is negative, there are three names for this: negative acceleration, deceleration, retardation. Remember one thing, in the question, if they ask you what is the deceleration or retardation, it means they already mentioned the negative sign. So you do not have to put negative sign. You have to write the values without the negative sign. That's what it means. Even though you get with a negative acceleration, negative value, but you have to put it without the negative sign, because retardation itself means the value is negative. Understand?
Yeah.
Okay, let's start another equation. Can you see this equation anywhere? S is equal to Vt. What is this equation?
Mm, Displacement equals to velocity times time.
Yeah. And this equation will be used when acceleration is 0. Or you can say body is moving with uniform velocity. Acceleration 0 means body is moving with the uniform velocity. This formula can only be used in that conditions. Now we are actually deriving few equations when acceleration will be there and each and everything will be there. So I want you to start the derivation. Put a heading derivation and we will start derivating. Let's see. Let an object move with an initial velocity of u. Let an object moves with an initial velocity u. After time small t, the velocity changes to capital V. After time small t, the velocity changes to capital V. There will be a constant acceleration. There will be a constant acceleration during that period. During that period, there will be a constant acceleration, small a, during that period. Distance traveled during that period will be capital S. Distance traveled during that period will be capital S. I want you to draw that diagram. Is that my car is not that good actually. So don't blame me. My diagram is not good. If somebody of you have a good diagram, please draw it. At this point, the initial velocity is u. The velocity changes to u. The time taken is t, and the acceleration for that path is, I take it as a constant acceleration. And during that, the distance traveled will be s. Now, this formula S is equal to u. Vt is, as I told you, formula when the body is moving with a uniform velocity. But if we can write this one, v plus u divided by 2 into t. Now this formula can be used for the purpose because we are finding the average velocity here. Initial velocity plus the final velocity divided by 2. So the formula we use that will be, just write further. The formula we can use to find the distance can be S is equal to u plus v divided by 2 into t. I want you to write that because this will be the formula which will we proceed further and we will actually deduce a new formula. Students, do we have a class on Friday or not?
We do.
Okay.
Yeah.
Might be, maybe this Friday I may not be able to take a class because the reason is, me and my family has to go outside for, Eid shopping or something like that. I will let you know beforehand anyway.
Okay.
Eid is very
Maybe we
nearby,
will
so
also go.
yeah. So I will let you know if I will not go, like, then I definitely we will have our class. Otherwise, I will message you in the group. We will compensate it afterwards. Don't worry about this. Okay, this is the standard formula. Now we will manipulate the values into this formula and we will find two different formulas to find out the distance. That will be your distance formulas. And then these two formulas, including the third one we have just derived few minutes ago, we will combine these formulas and then these formulas will be used to solve the problems. Alicia asked one of the questions related to that as well. Then we will see how to actually solve our question by using these three formulas. Okay. So I think we will stop our class here, right? And in the next class, we will be inshallah continuing that. So I think we better stop our class.